Once you learn about isotopic age dating, the question comes about what can you actually date and what does that date even mean? And this could be a really complex question. I'm going to answer at a very basic level, and I'm going to talk about two different isotopes and talk about what they can each date. So uranium and carbon. So you may have learned that uranium decays to lead, carbon decays to nitrogen, but these things happen in two very different places. Let's look at uranium first. This decay from uranium to lead is going to occur in a meaningful way in igneous and metamorphic rocks. And that's because we know that that decay process, where you have 100% uranium decaying into lead, is going to start when that rock reaches a particular temperature. So temperature is key. So temp is key. And so you can picture like a molten material. So this is a melt. And that melt is going to have all uranium, so 100 uranium, and 0 leads. So Pb is our symbol for lead. And so it's going to start that decay once you hit a certain temperature. So you're going to turn this into a rock. Those minerals are going to hit a certain temperature, and then the decay starts. So what you're really dating with that is when it hits a certain temperature, so when it crystallized and formed into solid rocks. So because you're dating that cooling, then you can really only use this on rocks that cool. So that would be igneous rocks, starts to melt, cools to a solid, and that could be either lava or magma. So on the surface, below the surface, doesn't matter, they'll work the same way. Or you could take something like a metamorphic rock, because what happens is, let's say that you have this rock that gets heated up to a certain temperature and metamorphosed, it resets that clock. So even though the starting material may have had some age to it, as soon as you heat it up, you go to this 100-0 mix of things, and then as it cools back down, that clock starts counting again. So uranium can be used to date either igneous or metamorphic rocks, anything that cools. If we look at carbon, it's a little bit different. So our carbon-14 to nitrogen, that's occurring in living materials. So the key part is here is living materials. Now we know that rocks were never alive, they never die, but what does live and then come to some end point is going to be something like grasses or leaves or anything of that sort of nature. So if we think about, like, say, a layer of grassy material that might die off, as soon as it dies off, that carbon starts to decay to nitrogen. So here, where we've got our living grass, it's all happy and alive, we've got 100 carbon and we have 0 nitrogens. But as soon as that decays and decomposes, so we're going to decompose into this organic material, there's our organic material, then we start our decay. So our decay starts here. So what you're really dating with carbon dating is going to be when that organic material died. Now that's not super helpful because that's not a rock. But what happens is you might have this grassy layer and it might have some sand and sediment put on top of it. So on top of that organic layer, you would get this sand here. So here's all of our sand that's sitting in here. And so you can infer the age, that the age of the sand is going to be pretty similar to the age of that organic material. So when you're using carbon dating, what you're actually dating is going to be the approximate age of the sediment immediately below and immediately above that.